We are finding the derivatives of functions that have natural log in them today is what we're looking at. Okay, we have pretty much learned all of the concepts except for area and volume, which we'll get to later, and area and volume shouldn't be that big of a deal. So we've learned all the concepts, how to apply all the calculus stuff for the most part. We need to go back and pick up a couple things on how to take the derivative of a few things. One of them is the natural log, okay, and it's pretty easy to do.
The other one, inverses.
We have to do that as well, but I'm not big on inverses because they might show up one time.
Oh, I like that. On the AP test?
I could afford to not
Like
get
inverse trig stuff,
Yeah.
derivatives of inverse trig stuff, it might show up once. So if you got everything else on lockdown, then spend some time on it, get it memorized. Okay, but your time is better spent other places versus memorizing that when we get to that later. All right, so derivative of natural log of x is 1 over x.
That's
Is
it.
there any
Is that
method
just
behind that?
That's nice.
That's it. Now, if there, what is this one telling me? The derivative of the natural log of g of x. What is this one telling me? What does the g of x represent? Another function that is inside of that. So I have to do the chain rule. So if there's something inside of it, you got to do 1 over what's on the inside times the derivative of the inside.
Chain rule.
Yes.
That's not the. Is that the U?
No. U is when you integrate.
Oh, we're taking derivatives.
Natural logarithm differentiation, you will find the derivative of functions involving natural log.
Are we going to do integrals next?
We will. So, speaking of integrals, if I'm taking the derivative and I get this, what's the integral of this going to be?
Natural log.
Natural log. So we'll get to that later. But what you need to know is the derivative of the natural log is 1 over the inside times the derivative of the inside. That's all there is to it. So the rest of the day, we're just using that among our other differentiation rules. What are our other differentiation rules? Quotient. Motion. Product. Chain. That kind of stuff. So we're just mixing that into all that other stuff. So number 1 down here, I want the derivative of the natural log of 4x. So how do I find it?
1
over
over
4x times 4.
1 over 4x times 4, which gives me
1 over x.
1 over x.
What the heck?
So is it always like that?
If
It's like just a constant versus a variable?
if it's just a constant and a variable, or a coefficient and a variable, it will always give you 1 over x.
That's nice to know.
Next one. I want the natural log of 3x squared minus 5x plus 8. So 1 over the inside times the derivative of the inside. So obviously the best way to write this would be 6 minus 5 over 3x squared minus 5x plus 8. So what's another way we can think about finding the derivative of natural log when you look at that?
With a calculator.
Not the mood, Harrison.
I was being serious.
What's in the numerator?
Derivative over original?
Derivative of the inside, and what's in the bottom? The inside. So what's the derivative of natural log?
Derivative of the inside over the inside.
Derivative of the inside over the inside. So that's another way you can think about it.
Well, shit.
So if I go to 3, what's the derivative of the inside?
5x to the 4th.
5x to the 4th. What's the inside?
X is good.
X to the 5th. What do we end up with? 5 over x.
Okay.
Remind me to come back to number 3 after we get to the back page.
Okay.
Alright, number 4. I have y equals x squared times the natural log of x. What has to happen? Product rule.
First times the derivative of the second, plus second times the derivative of the first.
Very good. So first times the derivative of the second plus the second times the derivative of the first. So that gives me x plus the natural log of x times 2x. Anytime we do product rule or quotient rule, what should we always be looking to do?
Back of something.
factor something out is what we usually do. So taking x out, 1 plus 2 natural log of x is the best looking answer.
Why do you say that 2 to the 4?
I just like my coefficients to be in front. Looks
So-
pretty.
If it was natural log 2x, I'd be correct.
What is your question? If you, this is technically correct.
If you move, if it's negative 2x, you move the negative out.
The negative would have to go there.
Is that what you want?
Yes. All right, next one, number 5. What has to be done with number 5? Quotient. Brady, remind everybody what the quotient is. Brock, let me know when you're ready.
Bottom times derivative of top minus top times derivative of bottom over bottom squared.
So we end up with 1 minus the natural log of x over x squared.
That's 6.
And works in one.
Once I get to the center, do I need to borrow a pencil?
Pencil would probably be a better approach.
Is there this with regular logs on the bases or something?
It used to be a radius.
Radius. No, you're not using. Is that the first part? All right, we're going to skip past 6. 6 is the same thing, except they just switched it. You're still doing the quotient rule. Let's move to 7.
Can we rewrite that?
On 7, yes, that is what I would recommend. So how am I going to rewrite it?
Natural log of x.
Well, actually, we'll do that, and then we'll come back and show you another way. So this is the same thing as the natural log of x to the 1/2, correct?
Yeah.
So Justice, what do I have to do there?
And you have to remove it out and then keep the inside and subtract 1 and take the derivative.
Very good. So we end up with 1 over 2x, natural log of x, to the 1/2. Now let me show you something that's a little bit quicker. Who remembers the shortcut to finding the derivative of square root? 1 over 2 times the square root times the derivative of the inside. There it is, same thing, a little bit quicker. But remember, that only works if it's a square root. Other
It's a
roots,
cube root, is it 1 over 3?
cube root doesn't work, no.
And then natural log and natural log.
All right, number 8. I have y equals cosine of the natural log of x. Chain. So what's the derivative of the outside?
Negative sign.
Negative sign. Inside stays the same. Derivative of the inside, 1 over x. So negative sine natural log of x over x. Okay, number 9, y equals the natural log of the natural log of x. So, what do I do there? Chain rule. Chain rule. So what's it going to look like?
1 over x.
1 over the natural log of x.
1 over the natural log of x.
1
Times 1 over x. So we get 1 over x. Natural log of x.
I'm confused.
Derivative of the outside. How do we take the derivative of a natural log? 1 over the inside. So the derivative of this is that. Then I need the derivative of the inside. What's the derivative of the natural log of x? 1 over x. So we have 1 over x natural log of x. Alright, now it is helpful to remember our three basic properties of logarithms from last year, and you're out for 2 days. Because it makes finding derivatives easier. This first one, what's this first one telling me?
Add the product.
If it's
Well,
multiplying, you can split it up.
If it's being multiplied inside, I can separate it using addition. If it's division inside, I can separate using subtraction. And if I have an exponent on the inside, I can move the exponent to the front. You guys remember those three things?
Yeah.
Sound familiar?
I just don't remember how to remove that.
So, if we go back to number 3, what's something I can do to number 3?
Move the exponent to the
I can
front.
move the 5 to the front, and then I can take the derivative. Which gives me 5 over x, which is the same answer we got earlier, right?
Move the
Yeah.
5, just stay.
The 5 stays because it's a coefficient.
Oh,
Okay, so there's an example, but now we're going to do it on a bigger scale. So let's look at number 10. So number 10, what's something I can do to 10?
put a 1/2.
Bring the 1/2 to the front. Now I'm ready to take the derivative. The 1/2 stays there. How do I take the derivative of the natural log of x squared plus 2x minus 3?
1 or derivative over the inside.
So 2x plus 2, or yeah, 2x plus 2 over x squared plus 2x minus 3. What do you see we can do there? Take out a 2 and cancel it. So the best looking answer is x plus 1 over x squared plus 2x minus 3. What would I have had to have done if I didn't move the 1/2 to the front to take the derivative?
Chain rule.
I'd have to do the chain rule. I'd have to do 1 over the radical, and then what would I have to do?
Find the derivative.
Find the derivative of the radical, which gets pretty messy. So obviously you see that this is a better way to do it. Number 11. I have y equals the natural log of x squared over 3x minus 2. What do I do here?
Subtraction.
Subtraction, and what can I do with the square on the x?
Take it out.
Take it out front. So this can look like 2 natural log of x minus the natural log of 3x minus 2. Notice how I put parentheses around the 3x minus 2. Make sure you do that so you know what's inside the log. Now take the derivative. So the derivative of 2 natural log of x is
2 over x.
2 over x. And the derivative of natural log of 3x minus 2.
3 over 3x minus 2.
Okay. Now, if this is multiple choice, that right there, that answer right there is probably not going to be what's going to be the multiple choice answer. What do you think you're going to do to get the multiple choice answer? Common denominator, so keep that in mind. All right, number 12.
What do you do to find common denominator? You do that. Oh,
And so on, and just simplify it.
and that's it?
That's probably what they're going to do.
Okay.
All right, number 12. I have y equals the natural log of x times the square root of 3x minus 1. Who wants to separate that all the way out for me? AJ? Knock it out for me. What? Janine? Not yet.
Take them to addition.
I need to separate it by addition because what's going on first?
The x times this.
The x, there's being multiplication. So the natural log of x. On the second one, I can bring the 1/2 out. Because the 1/2 only goes to the 3x minus 1. So I can do the natural log of x plus 1/2 natural log of 3x minus 1. Now we're ready to take the derivative. So I have 1 over x plus the 1/2 stays there, and then the derivative would be 3 over 3x minus 1. So make that a little bit prettier. 1 over x plus 3 over 2 times 3x minus 1. Again, if it's multiple choice, they'll be getting the denominator. But I'm more concerned with the calculus. All right, Erica, split 13 up for me.
Because I made that noise. Really.
You got my attention.
Move 1/2 in front.
Okay,
That much I can
you can do more than that.
do. Do you have to do quotient?
I can do something better and make it easier so I don't have to do the question. What do we do with division inside of the log?
Oh, the subtraction.
Subtraction. And make sure you notice that since everything was in the square root, I put the 1/2 out front and everything in parentheses. Or you can put a 1/2 on each one of them, whichever one you like. Now take the derivative. So the 1/2 stays there. Then I have 2x over x squared plus 1 minus 2x over x squared minus 1. There could be one more thing to make it pretty, and it wouldn't be too time consuming. What is that one thing?
Should be the 2.
Yeah, the 2's. So make it just x over x squared plus 1 minus x over x squared minus 1. All right, 14. X squared minus 3. Natural log of y plus y squared equals 25.
Solve for 1.
Do not need to solve for y. Chelsea, what do I do on this
Don't look at me.
one? I'm looking right at
You have no idea.
you.
Get the log by itself.
No.
Well, I don't know.
Kelly?
Solve for x.
You guys are thinking too hard.
Take the derivative.
Take the derivative. What type of derivative is this? What type of differentiation is this?
It's the complicated one. It's don't know if complicated.
Implicit.
Implicit. What does implicit differentiation require me to do when I'm taking derivative?
I don't know.
Whenever I take the derivative of y, I've got to put one of two things down. Y prime or dy dx.
dx.
So we have 2x minus 3, 1 over y, y prime plus 2y, y prime equals the derivative of 25 is 0.
What's after that y prime? That plus?
Yes. Alright, now what?
Solve for y prime.
Solve for y prime. What would I do first to make this problem easier to solve for y prime?
Subtract the 2x.
Get rid of
Take
the
away.
y.
I would multiply by y to get rid of the fraction. Is what I would do.
Okay, it's 1.
Then what do we want to do? Okay, speak up, Justice.
Get y prime by itself.
Okay, I've got 2 of them, so keep those 2 together and move the other one over. So negative 3y prime plus 2y squared y prime equals negative 2xy.
Factor your y prime.
Take my y prime out. And then all I have to do is divide. Oops. Here it is.
It's the answer.
That's my answer. Once I get y prime by itself, we're done.
How come everything above was y prime? Or was it?
Yeah, it pretty much was. We may not have written it down, but it was understood that we were finding y prime.
Oh, okay.
Alright, 15. Find the relative extrema of y equals the natural log of x squared plus 4x plus 6.
Derivative same equals 0 somewhere.
Very good. So I need the derivative. So that would be 2x plus 4 over x squared plus 4x plus 6. Make sure you set the whole thing equal to 0. And set your parts. So 0 equals 2x plus 4. What do I get out of that? Negative 2. 0 equals x squared plus 4x plus 6. What should I try to do to that?
Thanks.
Factor.
Yes, yes, that's what
But
it's
that thing won't factor.
called.
Will not.
Well,
So I have to use the quadratic formula.
Why?
Holy smokes! You gotta be kidding me.
You just tell us what x is?
Negative b plus or minus.
Negative b plus or minus square root of b squared minus 4ac over 2a. So what is b? What is b? 4 plus or minus the square root. B squared would give me 16 minus 4 times a. What's a? 1 times c is 6 all over 2 times a, which just gives me 2. But something nice happens for us. What's the something nice that happens for us on this problem?
Radical.
What about the radical?
You can take the square root of whatever that is.
I can,
Can't.
because I can. Because 16 minus 24 is negative. We're not dealing in imaginary numbers, so that one will not produce a real 0. So now what do I do?
Number one.
Sign line. Negative 2. Will my signs change?
Yes.
Why?
There's no
No multiplicity. What's the easiest number to plug in?
0.
Where do I plug it in?
X. Positive.
Which function?
Oh,
No.
That
The
last
derivative.
line.
What do we get from the original?
Your y.
Y values. If I'm dealing with the derivative, I want to do the derivative. So I plug 0 into the top, it's positive. 0 into the bottom, it's also positive.
So you not plug in 0 to 2x plus 4?
No, you need to plug it in before you split it up. So what do I have at negative 2?
We don't submit.
Because
Changes from
what does?
to positive.
Y prime changes from negative to positive. If I wanted to find the minimum value, what would I do? Because that's where the minimum is at. Where do I get the minimum value from?
Plug in negative 2 for x.
Plug negative 2 where?
X.
Into the original.
For x.
Correct. Alright, last one, 16. Find the equation of a line tangent to y equals 4x squared minus the natural log of x at 0.14. AJ, what do I need to be able to write the equation of a tangent line? Yes, you do. You need 2 things to write the equation of a tangent line. What do we need?
I literally
Janine, what do I need? And? Erica? I need the derivative to get the slope. And what else do I need, Chelsea? The point, which they gave. So, what do I do here?
Derivative.
Derivative. So y prime equals 8x minus what over x? Now what?
Plug in.
Plug in 1. So that gives me 8 minus 1. So I have 7. So Harrison, the equation of my line tangent is y
Minus
4 equals
7. X minus 1.
Thank you, Harrison. Alright, so that is finding the derivatives of functions that have the natural log inside of them. So not much new there. The only thing new is the derivative of natural log is 1 over the inside times derivative of the inside.
So you don't plug in 4
That is the only thing new.
ever. You never need to plug in 4 to find anything.
That is incorrect. What if I wanted the slope of the tangent line of this bad boy?
Are you plugging both?
I have to plug in both because my derivative has both. So if my derivative only has x, then I've only got to plug in x. If my derivative has both, I got to plug in both. And what if they give me one, but I don't have the other?
Plugging into the original.
Plug it in the original to find the other. Good. All right, very nice.